Here's an example of simplifying a complex rational expression. You can see this example. This is a complex rational expression because there's a smaller little rational expression in the numerator. There's also one in the denominator. So when that happens, it's a complex rational expression and it is not simplified. You just can't leave it that way. You're going to have to somehow get rid of this smaller little denominator and this smaller one also. To do that, what you do is multiply the numerator of the rational expression and the denominator by the least common denominator of these small ones. This small one is x, this small one is x plus 1, so least common denominator is the product of the two, x times x plus 1. Alright, so I'm going to write this step out where I'm distributing the x times x plus 1 into both of these terms in the numerator. X times x plus 1 times 1 will just give x times the quantity x plus 1. Then when you take x times x plus 1 times this little rational expression, it'll look like this. You do the same thing in the denominator. The x times x plus 1 gets multiplied by this little rational expression here, so it goes in the numerator and looks like this. X times the quantity x plus 1 divided by x. Alright, I took all of this, went into the numerator here, multiplied by that first term. Alright, we also have to do the same thing with the 2, it's minus 2, times x times the quantity x plus 1. Alright, I wrote this step out so that you can see what cancels. The x plus 1's will cancel, as well as those x's will cancel. That's exactly what I wanted, because I wanted to get rid of those smaller denominators. So in the next step, you have x times the quantity x plus 1, then you'll have a plus x. In the denominator, you'll have x plus 1 minus 2x times the quantity x plus 1. Okay, let's distribute to get rid of these parentheses. Got a set of parentheses in the numerator, set in the denominator. I'm going to distribute. So back in the numerator, I'll have x squared plus x. Down in the denominator, here's my x plus 1 that was right there, minus, distributing a negative 2x through here, it's negative 2x squared minus 2x. Now, we'll combine like terms, and up in the numerator, there's that x squared plus 2x, and in the denominator, let's put this in descending order. I've got a negative 2x squared out front. My x term is minus x. My constant is a plus 1. Now, you actually could leave your answer this way, but technically you should factor it to see if there's any common factors that you can cancel top and bottom to see if we could simplify this. So if we factor it, that numerator, we can pull out a common factor of x. And in the denominator, let's pull out, let me do it right here, let's pull out a negative first. So I'll have 2x squared plus x minus 1. So now let's see if that trinomial factors. I'm pretty sure it does. We'll have a 2x and an x. Let's put the plus 1 to be multiplied by the 2x and the minus 1 there. So if I check it, I'll have positive 2x minus 1x gives me my positive x right there. Alright, but you can see that there's no common factors. Up in the numerator I have an x plus 2, I also have an x. Down in the denominator, I've got a 2x minus 1 and I've got an x plus 1. So this is actually the best answer. It's in factored form, but this is also an acceptable answer. So what we did was simplified a complex rational expression by multiplying the entire numerator, the entire denominator, by the least common denominator of these little tiny smaller ones.